Welcome to the Explainer. Today, we're going to tackle a question that, let's be honest, trips up a lot of people in math. What's the real difference between a relation and a function? Let's break it down. Okay, let's kick things off with a little puzzle, just to get our brains warmed up. Look at these two ideas. On one side, you've got a person and their phone numbers. And yeah, they can have more than one, right? A work phone, a cell phone. Then on the other side, you have that same person and their single unique ID number. Now, one of these is just a simple relation, but the other, well, the other is a super precise, really powerful concept called a function. Stick with me, and you're going to know exactly which is which and why it matters so much. So, yeah, we're diving deep into these two fundamental ideas that cause a lot of confusion. At first glance, they seem pretty similar. They're both about connecting things. But one of them has this very specific, very important rule that makes it the absolute cornerstone of, well, everything from algebra to computer programming. All right, to really get a handle on functions, we've got to start with the bigger picture, the broader category they belong to. So let's talk about relations first. Think of them as the kind of wild, anything-goes starting point. So what is a relation, really? At its heart, it's just any kind of connection between two groups of things. We have a couple of fancy names for these groups. The starting group is the domain, those are your inputs, and the group they connect to is the range, your outputs. The key thing to remember here, for a relation, the rules are super, super loose. And here's a perfect example to make that clear. Let's say we're connecting students to their favorite subjects. Okay, so student B is linked to science. Simple enough. But check out student A. They're connected to both math and English. In the world of relations, that is totally okay. It's completely allowed. One input, student A, can have multiple outputs. That's a huge deal, so keep that in mind. All right, so we've got relations down. Now let's meet their much stricter, more organized sibling, the function. You see, a function is also a connection, but it lives by one very important, non-negotiable, unbreakable rule. And that rule is all about consistency. So here's the thing. Every single function is technically a relation, but not every relation gets the special honor of being called a function. And this is it. This is the golden rule, the one idea that makes functions so incredibly predictable and powerful. For every single input, you get exactly one output. That's it. No exceptions. No sometimes this, sometimes that. Just one clear, reliable answer. Every single time. A vending machine is maybe the most perfect real-world example of a function. Think about it. You press one button, that's your input, and you expect one specific snack to drop. That's your output. You press A2, you get the chips. You'd be pretty shocked if you pressed A2 and got both chips and a soda, right? That predictability, that trust, that's the whole point of a function. Each input is designed to map to exactly one output. Okay, let's put these two ideas head to head. This should really make the difference crystal clear. This table pretty much lays it all out for us. But the real decider, the row you absolutely have to focus on, is that second one about the input-output mapping. A relation is like our puzzle from the beginning. One person, multiple phone numbers. The input can link to several outputs. But a function, that's like the unique ID number. One student links to one and only one number. And if you're a visual person, there's this awesome little trick called the vertical line test. It's super simple. Just picture drawing or sliding a vertical line across a graph. If that line only ever hits your curve at one single point, no matter where you slide it, congratulations, you've got a function. But if you find even one spot where that line crosses the curve in two or more places, boom, it fails the test. It's still a relation for sure, but it's not a function. So because functions have this strict, predictable rule, we can start doing some really fascinating and powerful things with them. This predictability is what lets us build even more complex tools. For example, since functions are so orderly, some of them have what you can think of as a special undo button. We call it an inverse function. So if your function takes an input, say x, and turns it into an output y, the inverse function does the exact opposite. It takes y and gets you right back to where you started, back to x. Now, this only works for a special kind of function where the connection is a perfect one-to-one match. And it gets cooler. We can also chain functions together, almost like an assembly line. This is called composition. You basically take the answer, the output from your first function, and use it as the brand new starting point, the input for a second function. So here's how that works. You always work from the inside out.
You solve that inner function first. Then, whatever answer you get from that becomes the new input for the outer function. It's like a two-step process.
Okay, so what's the big deal? Why does any of this matter outside of a math class? Well, because functions are basically the engine of predictability in our world. They are everywhere. They're in the physics equations that let us send a rover to Mars. They're in the financial models that predict the economy. They are quite literally in the code running on the very device you're watching this on right now. Functions are the rules that make our modern technology work, period. So start looking around. The next time you see a system where one specific action leads to one predictable result, whether it's turning a key in your car or using your GPS, you'll know what you're looking at. It's a function. That one simple rule, one input, one output, is the hidden engine that makes our incredibly complex world tick. Thanks for tuning into The Explainer.